Welcome to our group presentation. We've met with a stroke prediction dataset and a logistic regression model. Looking at the data description, we can see that the response variable takes a binary outcome, with 1 being the patient had a stroke and 0 if not. Therefore, a logistic regression model was appropriate here. Looking at the predictor variables, there's quite a few, 10 variables. In the actual, for this presentation, we've reduced the 10 to 4. Reason being, some of the non-normal and categorical variables were splitting out errors in R, hence we're stuck with the numerical values for now. Given more time for this presentation, we'll dig deeper to debug the issue.
Here we have specified our model. First, we have written up a mathematical model. As you can see, we've considered 5 beta coefficients, beta 0 to beta 4, and we've considered 4 variables, x variables, as you can see, x1 to x4 as of now. We've also drawn up a model diagram to capture our JAG's model. So when it came to running our model, the parameters we fed in were as follows. So here we approach the diagnostic checking stage of the project. As you can see, we have plotted a couple of different plots for all the Z beta variables under consideration. Let's first look at the trace plots of each of the variables. As you can see, most of the variables assume stationarity in the trace plots, which is a good sign of representativeness. Then let's jump to the shrink factor plot. As you can see again, most of the shrink factors are under the value 1.1, which is again a good sign of representativeness. And lastly, we look at the convergence of each of the chains in the density plots, and convergence appears to be optimal in all the variables cases, again a good sign of representativeness. Now let's look at the accuracy stats of each of the plots. The autocorrelation plots disclose that autocorrelation is non-existent, and then we look at the ESS values, which roam around the 1700 to 2000 range, which is a high value, and it's inversely proportional to the autocorrelation, suggestive sign of accuracy. And finally, we look at the MCSC values. They are all close, very close to 0, which is again an incredible sign of accuracy. Similarly, diagnostic checking was undertaken for the predictions that we had made. As you can see from the plots, the results coincide with the diagnostic checking analysis that we have done for the Z beta variables. All the trace plots assume stationarity, or the shrink factors appear to be under 1.1, and the convergence of the chains are optimal mostly. Then the autocorrelation plots are signified by a lack of autocorrelation. Then the ESS values roam around the 2000s range, which is a good sign, and all the MCSE values are extremely close to 0. In conclusion, the insights we gained were as follows. The shrink factor across all parameters approached 1, and there was also optimal convergence of the chains in most of the plots. This suggested that the distributions were representative. The ESS and MCC values were optimal as well. ESS values were high, mostly above 1700, while MCC values were extremely close to 0. Also, the autocorrelation plots disclosed that autocorrelation was almost non-existent, or these suggested that the distributions were highly accurate. The posterior distribution for the parameters were well defined, with 95% highest density intervals. Overall, the diagnostic plot suggested that the model was a good fit and was pretty stable.